everyone, welcome to the Electric Supercar channel. Today we are still working on Clifford, the big red truck, and we are gonna get the motor spinning. It's working! Woo! So for those of you who are new, this is Clifford, the big red truck. It is a 1956 Ford F100. Clifford was undergoing an EV conversion when there was a couple mishaps that happened. So the biggest one was there was a pop, a bang, some smoke, and an EV fire. Not to worry, we've got the EV doctor here and everything is gonna be under control. Today we've got a lot to do, and by the end of the episode, hopefully we get the motor spinning. Let's get to it. One other thing this customer wants is they actually want a Frunk. So you might be wondering, what does that mean? What is a Frunk? So a Frunk is for EV cars. They've got a space usually in the front, which most cars have like an engine, but for us, we've got space that we can make a trunk in the front, a Frunk. And for this car, we have a very large space that we can put things. So the plan is we're gonna do a scan and we'll put in CAD, we'll make a spot that we can kind of have a recessed cavity to put things like suitcases, balls, bags, golf clubs, whatever. We're also probably gonna have a place, I'll call it like an access cover, so we can still easily get to these sorts of things. You know, the first step in our process is always scanning. And for today, we're gonna try out the Creality. This is the Otter Lite. So I'm actually quite surprised. I've used a couple scanners, even like really pricey scanners. This one, it keeps track really good and it is really fast. All right, here'll be another test to see how well it picks up. Yeah, kind of just picks right back up. Man, that looks really good. So again, I'm really impressed with how easily it could capture everything, because lots of times these sorts of units really struggle with dark surfaces, and essentially like all in here, this is all black. Just black paint, and it picked it up like just great. I mean, great. And it didn't have any problem, like it never lost track. That whole time, never lost track. And it was lightning fast and picking up all the points. So really impressed. So again, that looks pretty good. I'm liking that. Gives us kind of everything we need. So let's look at how to make this into a mesh. Okay, so this is the point cloud. This is the fusion. So now we're gonna do the mesh. So here it is. That is one good looking mesh. And you see the coloring's different, like for the back side versus the side we scanned. So that's looking good. I'm gonna go ahead and export it. We'll put it in a CAD, and from this, we will make our Frunk. Boom. We are still talking about the Creality scanner. It actually has a handle and you can connect it to your phone via an app. So basically then it becomes completely wireless.
So yeah, we're gonna go scan underneath the Jeep. Pretty easy. We just push this new scan button, start scan, and it looks just like it would on the computer.
All right, let's go take a scan.
And it's got really a pretty good amount of frames per second.
CAN is controller area network. That is a series of wires that communicates with lots of different elements in the car, like the battery management system, the motor, controller, charger, DC to DC converter. So there's a circuit in which all these are connected, and they have to be connected in a certain way. So let me show you real quick. So for simplistic reasons, what I'm showing you here is some of the components that may be in a system. So we've got things like your battery management system, DC to DC converter, your charger, display, some other times things like motors. So there's lots of things that can be on the circuit. But as mentioned, you have to do things a certain way. So this is a 2-wire system. So the red and blue represent a twisted pair. Usually want it twisted so it kind of cancels out any voltage that might be created by currents running back and forth. It's also best if it's shielded. So for this system to work properly, you need a 120 ohm resistor on one end and a 120 ohm resistor on the other end. That way communication can go back and forth and the system knows that like, hey, these are the ends. So what we're figuring out with Clifford, the big red truck, is that this system's not working and there may be either too many or too little resistors. So we're gonna dive into everything. Yeah, trying to diagnose some things and we're just finding questionable wiring. So we're just gonna probably redo it. Even these had some interesting connections. All right, just doing some CAN diagnosis. So I finally got everything unplugged and we got no resistance. When I start plugging things in though, some things have resistors, so I just gotta make sure those resistors are in the right place in the CAN line. So it just plugged in the Orion BMS Connect, and it's got a resistor. And then when I plug in the Orion itself, it also has a resistor. So we're getting around 60 ohms. The other one he had this little dongle. When that one's plugged in, we also get 60 ohms. So we unplugged that one. goes back to 120. So basically we have too many resistors. So there's one in here, one in there, one in there. Here is the plan. This one has a terminating resistor. This one has a terminating resistor. So we want those to be the ends of the CAN network. And right now they're just next in line, and that kind of goes up that way. So we're just going to redo this. I'm making my own CAN. So I've got this wire here that's actually got 2 wires, a shield, and a ground. So we're going to clip and replace the CAN wire. We're going to put this one at the end of the circuit and just rerun lines, splice, do all that fun stuff. So this is one branch. This is just so we can monitor things. But we're going to make essentially one to the BMS, one to the BMS connect. We'll have one for a dongle there. We've got one up front for the charger, the DC to DC and charger there. So this is where it's going to start because it's got a termination resistor. So we're going to go from there, pick up things along the way, and end in the engine bay with the other component that has a resistor. This end has this guy, which has a termination resistor, and got going up to here, which is also on the CAN network, and then back through the firewall. So through the firewall, through this mess, we actually have the dongle there, and we've also got this one that we can plug in and read CAN messages. And eventually it comes over to here, which also has a termination resistor. So that is this CAN circuit all finished up. So next up, we're gonna check all the wiring here for the battery management system. So if this all checks out, I believe we can start turning things on. All right, this is the motor plug. So we just undid this one, and it just has a lot of stray copper. Do you see that? And like up here as well, there's just, I don't know quite what's going on. We listen, but we don't judge. With that being said, yeah, this all needs to get kind of replaced. Oh yeah, even one of these pins was like way out. Man, how'd they do this with their pins? It's just scary. One, got like a gazillion to go. 2. I'm not gonna keep counting. All right, we got the plug remade and plugged in. Probably use a couple cable ties, get things, make sure they're out of the way, but this one is good. Here is the state of the high voltage junction box. So we're gonna unravel some of the electrical tape and kind of sort things out, make sure things are looking good. Even though I've disconnected the battery under the car, I always treat things like they're live. So got my voltmeter here. I'm just gonna make sure that there's no high voltage before I dive in. We are good. There's no voltage across anywhere. So we're good to go. So I will show one thing here. So this contactor, again, they should normally be open. So like this one's normally open. This one though is closed. That likely means it's been welded shut. So we'll probably have to look at maybe replacing this one. There you go. We are in the middle of redoing the high voltage junction box, and this is the current sensor, and it was just kind of hanging out. So modeled and 3D printed a bracket. So we're gonna go ahead and fasten this one. It goes like so. We're gonna fasten this one so it can get bolted down. Boom. All right, I've been taking some time to redo this high voltage junction box. So what I did is I made a plate at the bottom. This currently is just a 3D printed plate. I wanted to make sure all the components fit and that we needed to change anything, that'd be easy to do. So I do need to make a change. So this one is just a little bit too far over. I need to scoot, make this bus bar like an inch longer. So this is the one side of the battery, and it's going through this switch, so kind of a cutoff switch. Then it's going over here to this contactor. Then from this contactor, we're gonna have that be a cable that just goes straight out here. So cable out to here. And that will be the one side. The other side comes over here, and you can see I've got a bus bar there. This one, this cable will be attached to the bus bar, go through the fuse. This is a current limiting fuse. And then it goes over here. We've got 2 contactors. One is going to go out to the motor. The other one is going to go to things like the DC to DC converter. We also have our pre-charge resistor. We did have to change, so this is what was currently there. These are just regular 12 volt fuses, and we don't want 12 volt fuses when we got 400 volts going through it. So we are replacing them with these. These are fuse holders and they are good up to 600 volts or something like that. And we're gonna put the appropriate size fuses in there for the components that we're using, like the DC to DC converter. So basically from the contactor, from the fuse, out through the hole, going to the DC to DC converter. The other one that we're changing, again, this is just a standard 12 volt relay. Again, where we're switching 400 volts, we don't want a 12 volt relay. So we've got another relay on order that will handle the 400 volts that we need. That one is going to be part of the pre-charge circuit. And so that just makes sure that the contactor doesn't stick when we're switching the voltage. So this one's just about there. This is a test fit. We've got kind of some of our, we'll call this like a negative ground bus. And so basically all of the contactors will go to that, as well as the relay, and then we'll have essentially 12 volt signals that'll come and close contactors, and those will go out to the controllers. So this is looking a lot better. We just need to make this bus bar a little bit longer, and then I think that's about it. I almost forgot, this is our current sensor, and it's gonna go right here. So basically all the energy has gotta go through this point, so that's where a good spot for our current sensor will be. So let's go ahead and put that one in. All right, that's better. Basically now the current sensor's in place. So we'll make the one change to this bus bar so it can reach the switch, and then I think we'll be good to go. All right, we've got the cables now coming from underneath, so we're just going to cut them to length, put some lugs on them, and start wiring everything in the high voltage junction box. Today we have a new vendor we're trying out. So this is from Oshcut. So Oshcut, they provide laser cutting and bending services for various metals. And the nice thing for me is they are local. So what is really cool is they're giving a special deal. They're gonna give 50% off, that's 50% off for your first order. So if you ever need something like this, I'll put a link in the video description below. Check them out. All right, so this is the final piece of the puzzle for the high voltage junction box. We did a 3D printed part to make sure we had all the spacing correct, and then we got this one made out of metal. So we're just gonna replace all that so we can button up the high voltage junction box. All right, this is my 3D printed current sensor holder, but I originally did this one just out of PLA, which would probably be okay, but we're up into nylon just to make sure. This is all complete now. So I've kind of gonna double check some things. I'll probably put a little electrical tape on some places that look like something might contact. Not that we're worried, but we always want to be double safe. Got some of the surfaces covered. Again, the thought is just to kind of minimize any accidental bridging. Obviously, as everything is, we don't have any problem. Tape doesn't really help. It's really just like if I were to drop a tool or something like that. That's what we're trying to reduce any likelihood of problems, but I think this is good. So we're testing out the high voltage junction box, just making sure everything functions as intended. There's a new high voltage relay for the pre-charge circuit that I was using, and I figured out that it's actually 2 tabs for the high voltage and 2 tabs for essentially the low voltage signal to close and open. What I learned though is it's actually like orientation dependent. So one, it'd be like normally open, the other way it's normally closed. So found that one out, but we'll show you here. This is positive contactor. So click 1, click 2 should be positive. So that's good. And then we'll do negative contactor. By the way, we don't have any high voltage hooked up, so we're okay. So it should be on click 1. Okay, and then here is pre-charge. Should be on click 1 and then off on click 2. So we are all good there. So yeah, I think this one's ready to go. We can start hooking up high voltage. Motor controller, it's connecting with the iPad, but it's not sending any signals, so I don't think it's connecting with the inverter yet. So we'll see if we can figure that out. All right, we have begun troubleshooting, going through all the various manuals. So found my first mistake. So this is the CAN adapter. It communicates with the BMS, and this is the plug I made, and I swapped high and low CAN wires. So see how nice that is? We're just gonna redo it. So I've got the BMS talking now. I've got some data. I've reconfigured the battery management file. That's the first part of troubleshooting. So now I think we're gonna get serious. We're gonna go ahead and plug in the high voltage. We're gonna monitor the high voltage junction box, make sure that everything there is looking good, nothing's overheating. And then we'll see if we can do things like charge, if we can get the motor to spin, DC to DC converter. So those are all things we're gonna work on next. All right, we're gonna try to turn it on high voltage for the first time. Hopefully no sparks or fires. So far, so good. So I've just got an IR camera. Make sure nothing's getting warm. Yeah, it seems like we're okay. All right, so we made it. We got the high voltage circuit to turn on. All the relays and contactors closed, and then they opened, but none of them were stuck shut. And we've got high voltage in all the places we want it to be. So I'll say that's step one. We've got a lot of troubleshooting ahead of us. So we'll probably start with charging and DC to DC converter. So I think I'm gonna tackle the easiest first. Well, I hope it's the easiest. I think this is the DC to DC converter. I think everything's correct, but I didn't do all the wiring. But there's a switch in the cab that will supposedly turn that on. So we just need to turn on the high voltage system, flip that switch, and hope that we see a voltage difference. So we just barely took this battery off the battery tender, so it is nice and high. So we may want to let it drain just a little bit so we can see voltage difference. All right, so high voltage system is on. We're at 1304. So we'll see DC to DC. On. And no, it is not any higher. We really didn't think we'd get that lucky, did we? So we'll check to make sure high voltage is getting to the DC to DC converter. And we'll also check kind of the signal wires and things like that. All right, step one. So this has got, I don't know, can you see it? Right there, there was a breaker, inline breaker that was tripped. So basically close that one and we've got the DC to DC working. So here we are, pretty close to 14 volts. I'll go ahead and flip the switch to turn it off. Yeah, so now we're dropping. So DC to DC is good. So we did pick the easiest one, but it is done. So that's one of 3 systems. The other 2 are usually a little more challenging. Got the motor and then charging. So the motor, I have to contact the company and we have to flash the motor. In the meantime, right now, I think we can try the charger. If that's not working, we're gonna boot that one to last. We're gonna try charging. Now, charging and we've had a troubled past. It never works, especially Orion. Orion's got like 50 ways to block charging and there's only one right way. So I'm gonna say there's less than a 2% chance that this works, but we'll give it a try. It clicked. It was promising. I'm used to a fan going on, but this one's water cooled. So we'll let it go for just a little bit. We'll keep a thermal camera on it, make sure things don't get too hot. But I wanna see if it's charging. It was at 369, so we'll let it go up at least 1 volt. So I believe it's working. So we've kind of connected to the charger here and it's commanded 400 volts roughly. I think it's working, but I'm not sure. Like I said, I'm gonna wait for it to go up to like 370 for the pack voltage. Okay, I spoke too soon. Right here, pack amperage, we're actually losing amps. So that's just because the high voltage system is on, DC to DC is on, things like that. So we're actually not charging, we're dropping. So see, we're 369.1. Before I think we were 369.2 or 0.4. So the protocol is being accepted, meaning it's got the handshake, it's saying, hey, go ahead and charge, but I think it's saying charge at 0 current. So we'll see if we can figure out what in the Orion needs to change to get this to work. Well, we got 1 step forward, 2 steps back. DC to DC is working. Charging seemed like it was communicating, but it wasn't charging. We just got a pretty serious warning on the Orion BMS that says there's an isolation fault. So when we're doing the troubleshooting, the voltmeter is our friend. So it kind of helps guide us to where the problem might be. So when I do the voltmeter from one leg of the high voltage to the frame, we're only getting half the voltage. So to me, that means it's one of the packs is got an issue. So I'm gonna disconnect the packs, find out which pack is causing the issue. All right, so here's what we've got. I've got one probe there on the negative side, and when I go to the car here, you'll see it starts out at like 350, but it's dropping. So you might not know what that means, but I do because I've had this happen before. So this is what happens when you have insufficient insulation or the high voltage is not sufficiently isolated from the chassis. So there's ways to detect this. Let me show you. So if it was directly touching, we would go to continuity and we'd do this, right? And it would be beeping. This one says, nope, it's over the limit. We have no continuity. It's not even measuring like a really high resistance. So we know we don't have a direct connection. All right, so this is my other meter. This is an isolation meter. So what this one does, it'll shoot, this one looks like we got it set up for 500 volts. You can do 1,000 volts. But basically this will tell you the resistance that there is in that circuit. So here we go. So again, this is mega ohms. So that's quite a bit of resistance. So basically what I do is I start disconnecting everywhere along the high voltage circuit, and I find that point where it drops, or essentially where we get a lot more resistance. That keys me into exactly where we're having the problem. I disconnected the battery packs from the high voltage junction box. That didn't really do anything, but then I separated the packs, and we've got a definite difference between the rear pack and the front pack. Let me show you. So the front pack is 0.3 mega ohms. So 0.3 mega ohms is not very much. The rear battery pack is like over 100. Let me do that real quick. All right, so it's actually only 96. When I say only 96 mega ohms. So 100 mega ohms or more is what I aim for. But yeah, this front battery box is like 100 times less than that. So unfortunately, I think what that means, we have to take it down again and find out where the problem is. All right, I was thinking I needed to take this down. I still may. But basically, the cell tap wires up there, when I unplugged them, we no longer have issues. All right, so we got one end plugged in there. The other end is going to the frame. And see, we've got like 300, 400, 500 mega ohms of resistance. So the problem is with those plugs or wires. So yeah, I may still need to get the battery box out just so we can manipulate those. All right, so this makes me feel a little bit better because I did test the battery boxes before I put them back in because I really didn't want to get them out. So this was about the same level I was seeing before I put them in. So the issue seems to be from those cell tap plugs up to the BMS. So we'll see if it's related to one plug, all the plugs. It's not gonna be awesome, but we've got to do it. All right, so here's the wire mess. I unplugged this one as well. The isolation didn't change, so these plugs seem to be okay. I think what I gotta do is go pin by pin and see which ones are having the problem. So I tested all the connectors, all the pins, and there were a couple that I thought were having issues. If it's kind of like no continuity at all, my reader goes to like 550 mega ohms. So basically all of them were 550 except for a couple. For modules 7 and 8, cells 1 through 6 on both of those, they all had a resistance of 3.2 mega ohms, which is very specific and didn't quite seem to jive. So I went up to the BMS and actually unplugged the plugs, and then they all read 550 again. So no issues with any of the wiring or plugs. I'm wondering if it's a BMS problem. So we're gonna plug it back into the battery with the BMS unplugged and make sure we don't have any high voltage issues, then plug it in to the BMS and see if those issues continue, which case it would mean it's the BMS that's the issue. Done some testing and figured out it is indeed the BMS that's causing the issue. So basically we've got the battery pack in, plugged in all the connectors, and they are all good. We don't have any voltage to chassis. We had good isolation on our isolation meter. And then when we plug in the BMS, we get bad isolation and we actually get voltage to the frame. So we're gonna unplug the BMS and we'll probably have to get a new one or at least send it out for repair. All right, we're still just getting enough problems with the BMS that I'm gonna try a couple more things. So I wanna get a baseline with this old BMS. I'll show you what the isolation values are. So 2.9, that's like low. Yeah, so those are low. What I'm gonna do is I'm gonna do nothing else but just swap out the BMS and see how much that changes. All right, so we just put in the new BMS. We're gonna see if that changes our isolation values. 100. God. Yeah, so that's a huge difference. All right, we're gonna do some testing with the motor. We believe all the wiring's correct, but the motor's not talking to the controller. So, got a backup motor, just in case that inverter is fried, because we've had that happen a time or two in the past. So this one we believe is a good one. We're gonna just hook it up real quick, see if we can get things to talk. All right, so just like that, we've taken the plug out of there, put it into there. We're gonna see if we get any communication. It's still showing all zeros. So I swapped out for a different inverter, essentially a different motor. I also swapped out for another T2C, and both of them are not getting any info, which means to me that I think it's more wiring related. So we'll go ahead and check some wiring and see if we can get things to work. For the motor, I've doubled and triple checked all the wires. Everything seems to be going to the right place. The only thing I am noticing is I'll call it the drive, reverse, neutral switch. This system wants like a momentary push. So you push and then off. I think this switch might be just like on, like it's toggled to neutral or it's toggled to reverse. I do wonder if potentially that is making it so that if you want to start the car, it doesn't want to see that activated. So I'm wondering if somehow that's like preventing an internal check and preventing the system from turning on and communicating. So I'm gonna try and dismantle that switch and see if we get any luck there. All right, we had to do a lot more troubleshooting than I was imagining for the motor controller. So the motor controller's in here and it would not talk to the inverter. And we made up a separate kind of harness and things to make sure we could talk to the inverter. And that wasn't working. Well, it turned out that one of these pins wasn't quite seated. So once that was seated, we were talking. I was worried that either the motor or the controller was actually damaged by the high voltage event. It seems like maybe they're okay. We're not gonna know for sure until we get all wired up. In here though, it's not. And again, I think we've got some wiring issues. Probably can't tell, but there's just, I think on this one here, there's like some copper showing and I don't think that one's set very well. So we're gonna redo this plug and hopefully we got some good results. Okay, I just rewired that whole plug. Because I did that, I'm gonna assume that none of the connections are good and I gotta recheck battery box and other connections. So I'm gonna do some troubleshooting, make sure everything looks good before we go further. All right, this is the app that connects to that via Bluetooth, and we've never been able to get anything to show up on here. And I finally think it was plug related, so that's why we redid all the plug wires. So hopefully when we turn the key, we get something on here. Otherwise, so we got some numbers. So anyways, I think that's better than nothing. Voltage of 5 volts is not what we wanna see. Oh, I've still got this turned off. So let me try turning that on. We'll recycle this again. So there we go, 369 volts, max drive power. So this might be working. So currently I've got all the wires for like drive, neutral, and reverse unplugged, but we still can change it with the app. So right there you see HV bus, or sorry, 12 volt bus is 12 volts. When I flip on our DC to DC, and we're at 13, so that's working. I'm gonna try to release the brakes. I don't know which way this. That sounded more like on than off. So I think, yeah, we can move them so the brakes are not on. So we'll try putting this into drive and see if anything happens. I can't remember, you may have to push the brake. So when I push the brake, nothing happens. So usually you get a red light right here where it's braking. So I think it's missing the brake signal. So we'll look at that. That's why we can't switch into gear. But yeah, we'll keep on going. So that fuse is broken. It doesn't look like it's burned out. It looks like it's just broken. But anyways, that was here and that one's going to the brake switch. So we'll replace that fuse and see if we're back in business. So I've run into this once before. This is with the brake switch. You see 1 and 2 are supposed to get power, fused power, and 3 and 4 are supposed to go to the inverter. And you see it's just a simple switch. One's normally closed, one's normally open. But I've encountered this before, and I don't know if there's some special sauce in this, but it's not working. So last time what I ended up doing is just getting a different switch from a different car manufacturer. So I'll try and show you real quick. It's pin 1 and pin 4. So normally open, and when I close the switch, I mean, I don't get any continuity either way. And then 2 and 3 are supposed to be. So this is supposed to be normally closed, but again, when I do the switch, nothing changes. So I don't know what the deal is. Here's a switch. See again, when you press it, continuity changes. So I don't know why that's not happening with this switch. I think it's something's not quite working. Okay, with this little switch here And this relay here, we're gonna make the a temporary braking circuit. Okay, remember here on the iPad, we had everything connected, so all the numbers were showing up, we just didn't get the red brake light. So I've now wired this switch with a relay, and now when I push the switch, the red brake light will come on. So now the hope is that we got the brake switch and the controller recognizes the brake switch. We can switch to drive. Nope. Reverse. Nope. Still got an issue. We'll have to figure that out. I did figure out for this brake switch, I thought I had troubles with this before, but it turns out there is this little, these semicircle things at the top. The black piece there, it can slide one way or the other. And if you slide it one way, there's essentially nothing, no brake signals come out. But when you slide it the other way, let me show you. So when you slide it the other way, then all of a sudden all the buttons and all the signals work. So if your brake switch isn't working, that's what you have to do. So there is the relay that I made. So I've taken that off and I put the fixed brake switch on. Now when I press the brake, you'll see the red light will light up. When I release it, it goes off. So we're back in business. Additional troubleshooting, we learned that one of the reasons we couldn't put it into park, neutral, or drive is because the controller was seeing that the accelerator pedal was pressed. Now we looked over the accelerator pedal and it is not pressed, meaning it's all the way up, but the controller saw that it was partially down. I'm not sure if that's an accelerator pedal issue, meaning I've not used that one before. I've always used the Tesla one. So what I'm gonna do is I'm gonna swap that for the Tesla pedal. So I just gotta redo all the wiring. Got the new accelerator pedal wired. We kind of temporarily have it mounted. We're not really gonna have it this close. Hopefully that'll help us see if everything's working. So before we had the 37 on the accelerator pedal, so that's why we couldn't shift into gear. So hopefully now we've got it all figured out and it'll shift into gear and we can watch the motor spin for the first time. Okay, so this looks like it's good. No accelerator pedal, so let's do the brake. Oh my gosh, you can hear it, you can hear it. It's working! Woo! So that is awesome. That must mean that the creep feature is on, so meaning it always kind of gives a little bit of propulsion, even if your foot's not on the accelerator pedal, kind of like a gas-powered car. We'll see if that's what the customer wants, but it's very exciting news. All right, I guess the other thing we should do is make sure we can go into reverse. So neutral, reverse. Whoa. And indeed, it's going in reverse. All right, well, we did it. We got the motor spinning. We're not done yet. Remember, we've got a lot of wheel and suspension problems, so that episode's coming soon. Thanks for tuning in. See you next time.